There's a lot here in 4.2, so let's get into it. The topic for this first part is isolating a variable with inverse operations. In the Desmos for 4.1, we saw how we can undo equations, and we're pretty much doing the same thing here. We're just talking a little bit more about how we're doing this. So of course, we're isolating the indicated variable and then filling in the blank for the statement that follows. So this first problem is asking us to solve for x, where we have a times x equals 7. So a and x are multiplying. They're butt up next to each other. So how can we undo multiplication? That's a question you should be asking yourself. How can we undo multiplication? What do you think? Hopefully you're saying using division. So I'm going to be using division on both sides. And if I want x to be equal to something, what do I have to get rid of on that left side of the equation? Hopefully you're saying a. So I'm dividing both sides by a. A will cancel here. I'm left with x on the left side, which is what I wanted. And on the right side, I'm left with 7 over a. So lo and behold, this was asking us to solve for x. I now have x equals something. So that's a good indicator that you did this right. How exactly did we do this? We can find 1x or x by dividing by a on both sides of the equation. Makes sense, right? That should help you solve 4 and 5. 6 is a little complex, so let's dive into 6. And that'll actually help you solve 3 also. So if you're looking for something similar to 1, 3, 4, and 5, those should help. But we'll dive into 6 because that can be a little complex. So this is asking us to solve for h. What's different about h this time around? What do you think? Hopefully you're saying that it's a negative h, which actually gives us 2 ways we can solve this, but I'm going to show pretty much the simple, or I'm going to show the more complex approach, where if I was trying to solve for h, I would probably want to leave h on its own, which would mean I have to get rid of 7. And if 7's positive, how can I get rid of a positive term? Remember, we're undoing the equation similar to 4.1. So how can I undo something that's positive? Hopefully you're saying using subtraction. So I'm going to subtract 7 on both sides. Got to give respect to both sides. So I'm now left with negative h equals 0 minus 7, which is negative 7. So my first step here was subtracting 7 on both sides. And then what can we do from here? This is a little challenging because we're left with negative h, and that doesn't match up with h. So any guesses as to how we can take this further? We're actually going to multiply both sides by negative 1. So let me clear this up a little bit. So we know that h is negative. And to work around this, we can change the sign of it if we multiply it by a negative 1. So if we multiply both sides by negative 1 times negative h is just positive h. Negative 7 times negative 1 is just going to be 7. Okay, and so what happened here? So at first I subtracted 7 on both sides, and then I multiplied. So then by multiplying negative 1 on both sides of the equation, we were able to solve and get h equals 7. Hope that helps. Pause. Think out these answers. Make sure that they make sense before we move forward. Again, we're undoing the equation, so we're thinking opposites there. That should help you. The set is going to look similar to our Desmos activity. All of the variables are given to us. We see that Jackson likes to be organized, so he made the following chart. He has decided to keep track of the miles he runs and the time he spends running. He attends PE class on Monday, Wednesday, and Friday, but he goes to school every day. So this includes Monday, Tuesday, Wednesday, Thursday, Friday. And let's assume that this is pre-pandemic where school was happening every day. All of the variables are given to you. You're being asked to fill in the type of units, so what's being counted or measured. This is pretty simple, I think, because almost all of it is referencing a number of something. So M is representing miles, W is representing miles, S is representing miles, but now from Jackson's house to the school. H is representing hours. This is representing minutes, minutes, minutes. So take all of these, put them here, and then let's get into it. For 11 through 17, make meaning of the expressions, write what they each mean. If an expression does not make sense, say why. Okay, so M, W, and F being added together. Well, these are all representing miles. So our unit would be miles. What do you think that is going to represent if we add the number of miles ran in PE class on Monday, Wednesday, and Friday? I'm going to say that this is representing the total number of miles Jackson runs in PE during the week. Because we only have one increment of Monday, Wednesday, and Friday. And if we add them all together, that's all of the running that Jackson's doing in PE class that week. And so we see a small change on 12. What's different about 12? What's different there? Well, we see 4 increments of that. So this is 4 increments of Monday, Wednesday, and Friday. Okay. And so I think of this as a month because there are 4 weeks in a month, right? So this would probably be the total number of miles Jackson runs in PE during a month, which makes sense because we have 4 increments of it, right? 2S, what's happening with 2S? Well, S is the number of miles from Jackson's house to the school. So maybe let's draw this out. So if we have Jackson's house, Jackson's crib, it's got a nice little roof. Jackson also has 2 windows, a little garage. It's funny, whenever someone tells you to draw a house, you end up drawing one of the houses that you've lived in. I think that's pretty funny. And then we know that there's a distance to escuela, scale, double doors, nice pink cloud above it. And so we know that S is representing the number of miles from the house to school. So what would 2 versions of that represent? Well, let's say that Jackson walks to school and then walks home. That's 2 versions of S, isn't it? So we could say that this is the number of miles Jackson walks to and fro school. Getting crazy with the linguistics here, to and fro school. But I think that's what's happening. I'll leave the other 3 up to you. Don't be afraid to draw out what's happening like I did for 13. The go, set notation to interval notation, inequalities on a numbered line. We've seen this notation on the left before, and I'll write out what that's saying. It's pretty much saying that X is an element of real numbers. Again, that's what that left side's saying. So we've seen that before. It's coming back again. But pretty much the inequality is what you want to look at here. So interval notation, set notation, we've seen that before. We see that this is going from -2 to 6. But how do we want to cap this off? If it's just less than and less than not equal to. How do we want to cap that off? Take a moment, get a quick refresher, think about it. Do we use brackets? Do we use parentheses? Do we use a bookmark? What do we use? Hopefully you're saying we use parentheses. There we go. Whenever we talk set notation, we're going to use the same type of thing that's written above. So X is being used, and it's an element of real numbers. And in this case, we're given the interval from -4 to 7. We're using brackets. So we want to say this is less than or equal to, less than or equal to, X is in the middle, and we'll cap out the whole scenario. We'll use a comma here also, and we're pretty much done. This 20 is a little challenging, but this is from -9, including -9, and everything greater than it. So we say that that goes to positive infinity. And I'll leave the rest to you. 26 through 31, this is so easy. You've done this before. The inequality, in this case, is saying that X is less than 6. So we could say that X is 5 or 4 or 0 or -1. So if we were graphing this, we want 6, we want an open circle, and we want to talk about all of the numbers that are less than that. So we would want to say that this is everything going to the right, right? Makes sense? Getting everything to the left where all the smaller numbers are. From -7 to 0. So we definitely want to work from -7 towards 0, just like a number line. I'm going to put, well, what kind of circle do you think I want on -7? Talking about 29, what kind of circle? Fill it up. Fill up my cup. Mazel tov. Open circle on 0. Don't be confused that this is another 0. This is referencing the type of circle. And we want everything in between. Let me bump that up so you can see it a little bit more. And so what this is doing is saying we want all of these numbers in between these two values to work. So we could reference that X could be equal to -6 or -1 or -3/2. Bottom portion, you've already done this before. So if you have any questions, holler, let me know. Thanks for watching and caring about your grade. That's what's up.